Okay, hello class. Good morning. Right. So today we continue for the exercise on reflection. Okay, on the reflection of wave. Okay. Okay. So today I will use one new apps. Okay. So maybe you already use it with other teacher. Okay. So I will give you. I will give you the link here. Okay. Right. I will give you the link here. Okay, and then I will give you the code. Okay. Wait for a moment. Right. So this is the code. Okay. So I will put the code in the chat box here. Okay. And for those who use the phone, okay, if you use a phone, you can just scan the QR code here. Right. And then you put your name. Okay. Please put your name. And for the attendance, please take the attendance. Okay. There are 34 of you. So four more. Student is not here. Monitor, can you please check who's still not in the class? Three more. If having a problem, you can tell me. Two more person. Wei Ying Wei, are you here? Wei Ying Wei. Okay, 34. Okay, one more. Who is still not here? Hmm, Wang Wang Zhenyep. Are you here? Wang Zhenyep. Did you join the link? Because I cannot see your name. Are you using another name? Wang Juliet. Kaylee, Alice, Cindy, Yin Hui. I cannot see your name here.
Yeah. Yeah.
Two more people. Oh, okay. So there are two more people missing here. Where's your penolong? Your assistant monitor? So your assistant monitor, please check the name for the participants here who still didn't join the link that I gave. The assistant, please check at the screen that I show you here, and the monitor, please check at the Google Meet. One more people, I don't have a link. Okay. This is the link, and the code is 72496. There's one more person who didn't join the class. Should be 38, right? Minus me 3 should be 38. Kaiser Tan didn't join the meet yet. Okay. Okay, so we should start first, then later they can join. Alright. Okay, so I want you to answer this question first. Okay, and please submit your answer. After you write your answer, submit to me. So which of the following characteristic of wave, okay, changes when the wave are reflected? Okay, so which one will change after the wave being reflected? Okay, for those who are just joined the class, so this is the link that you need to join, and also the code. Okay, 9 more percent, 7. Okay, I give you 30 seconds more. Just write the answer and then submit. Okay, two more, please. Ui Yingwei, you have two names here, is it? Uh, so you already submit or not? Okay. So mostly of you got answer A, right? Okay, so it says here, which of the following characteristic of wave change when the wave are reflected? So when the wave are reflected, so the only thing that change is actually the direction of propagation. Okay, the speed, the frequency, and also the wavelength will be constant. Okay, after the reflection and also before the reflection, the wavelength, the frequency, and the speed will be same. Only the one that change is actually the direction and of propagation or speed. Okay, sorry, or velocity. Velocity change because of the direction is changing. Okay, so number two, the answer is A. All right, very good. Okay, the next one. So the diagram shows the wave fronts of a plane wave, okay, incident on the plane reflector. So which statement is correct about the reflected and incident wave?
Yeah. Yeah.
Okay, 16 more. Okay, I give 30 seconds. Chen Yep, Kaiser, please answer the question. Kaiser, are you here? Okay, never mind. All right. Okay, so it says here the diagram shows the wavefronts of a plane wave, okay, incident on the plane reflector. All right, wait for a moment. 72496. Okay, which statement is correct about the reflected and the incident wave? So this one for A, okay, the speed of the reflected wave is the same as the speed of the incident wave. Okay, so before and after reflection, the speed is same. Okay, but the velocity is different. Okay, so let's move on to the next one. So diagram below shows a sound wave, okay, reflected from a concrete wave. So which comparison is correct about the reflected sound wave and also the incident sound wave? Kavinesh, Lo, Chi Seng. Okay, so let's check the answer. So most of you answer is B, some answer C. Okay, and the speed of the incident wave and the reflected wave is same. Okay, D, B, A. Okay, so there's many answer here, right? B, D, A, some answer C. Okay, so let's see what's the correct answer. So it says here this is the reflection of sound. Okay, so whether it's reflection of sound or reflection of water wave, okay, the characteristic of the reflection is all same. So means the speed, okay, the frequency, the velocity, and also the wavelength will be same. Okay, before and after the reflection. And for this one, it says the wavelength of the incident wave is shorter than reflected wave. Okay, for reflection, okay, like I told you just now, even for sound or even for water, the wavelength will be same after the reflection. So means for A, the answer is wrong. Okay, for B, the speed of the incident wave and the reflected wave is same. So yes, that's the correct answer. The speed is same, right? C, the frequency of the incident wave is less than the reflected wave. The frequency also same. V, F, lambda, all of it same before and after it being reflected. Okay, and for D, the angle of incident. Okay, so you already learned that the law of reflection. So what does the law of reflection say? The incident angle must be same with the reflected angle. Okay, I is equals to R, like this. Okay, I is equals to R. Okay, so this is the law of reflection. Okay, the angle of incidence must be same with the angle of reflection. So D is also wrong. So the answer is B. Okay, so remember, it doesn't matter water wave or sound wave. Okay, the characteristic of the reflection is same. Okay, there will no change in speed, in frequency, and also in the wavelength, and also in the frequency. The only thing change is direction of propagation or velocity. Velocity change because of the direction, because you know that already velocity is a vector, so it has to depend on the direction. Okay, even the magnitude is same, but because the direction is not same, so that's why we said the velocity is not same, only the speed is same. Okay, so number four. So the number 4, the answer is B. Okay, let's move on to the next one. Yeah, you have to calculate the value of D, the depth of the seabed. So what the formula that we should use here? Okay, remember last week on this day, I think, remember I said that the submarine, okay, they can use the reflection of wave, reflection of ultrasonic wave, right, to find out what is the depth of the seabed, okay, or maybe like the bed, okay, the bed also use the reflection of wave, okay, to detect the obstacle, okay. So how does they estimate? They estimate the distance. Okay, what is the formula? V is equals to what over T? Yeah, I give you a clue. Okay, V equals to what over T? Or some is said like, or some will use S is equals to over what over 2. Okay. Kelly, Wendy, Chen Yap, Yong Wei. Okay, I give 30 seconds. Okay, so let's say if you don't know, you just put I don't know. Okay, just put I don't know. But you have to submit, so we didn't have to wait so long, right? Yong Wei. Okay, close the submission now. All right, so let's check the answer. So here, most of you, oh sorry. Okay, so most of you put answer A, B, C. Okay, never mind. Right, so let's check the answer. So what's the formula that you should use here? Right, so this one is actually V is equals to 2S over T. Okay, and here it already give you, the diagram shows the ultrasonic wave transmitted from a boat to the seabed to determine the depth of the sea. So the speed of the ultrasonic wave is 1500 and the echo of the wave is received 2 seconds after the transmission. So what is the value of D? What is the value of the depth here? So mean this one is actually they ask you to find the distance, okay, S here. So V is actually the speed that is 1500, okay, and the distance you need to find, and the time is 2 seconds. Okay, so this one will become 3000, 2s, right, and s will become 1500, right? So the answer should be C. Okay, the answer should be C. So just use this formula if you want to find the depth, okay, of the water for the ultrasonic wave, okay, or sometime for the submarine, okay, or sometime if they want the fishermen, right, if they want to find the fish, okay, so they use also the ultrasonic wave. Okay, so you can calculate the depth of the water here, okay, using the reflection of wave, okay, by using this formula. V is equals to 2s over t. Okay, so let's move on to the next one. So here it says a radar transmit. Okay, a radar transmit a signal towards an aeroplane. The velocity is 3 times 10 power of 8. Okay, 3 times 10 power of 8. After 4 times 10 power of negative 3 seconds, the radar detects the reflected signal, right? What is the distance of the aeroplane from the radar? Okay, this one is just same like question number 5. Okay, you're using that formula, okay, to find the distance. Okay, but distance in the formula is actually s. Okay, v is equals to 2s over t. Did you find the answer for this one? What is the distance? Okay, Kavinesh. Okay. Right, so all of you got C. Okay, except for Yove got D. Chiseng got B. Chiseng got A. Wai Hong got B. Lavanya got D donkey. Okay, so let's check the answer. So this one also we use V is equals to 2S over T, right? So the velocity here is 3 times 10 power of 8, right? And you want to find the distance, there is 2S. Okay, and then the time here is said it will be reflected. Okay, so the time taken to be reflect is 4 times 10 power of negative 3. Okay, so you just multiply 3 exponent 8. okay, 3 exponent 8 multiplied by 4 exponent negative 3, you will get like 1,200,000 like that. Okay, and then you divide by 2, so you get like 600,000. Okay, and you have to change 600,000 to, okay, to standard form. 1, 2, 3, 4, 5. So the answer is 6 times 10 power of 5 meter. So the answer is C, right? Okay, so for this one, which of the following graph shows the correct relationship between the wavelength and the frequency of the wave? Okay, so this one you have to refer back to the formula. Okay, V that is equals to F lambda. Okay, so from here you can find the relationship between the wavelength and also the frequency. Okay, if you don't know, you just put I don't know, okay, and submit. It's okay. Jun Kiat, Lu Li Jingyi, Yong Wei, Kaiser. Lu Ling Jingyi, where are you? Okay, so I just end first. Okay, some of you answer A, B, C. So A, C. So mostly answer A and C, right? Okay, so let's see what's the real answer here. Okay, so here I ask you to find the relationship between the wavelength and also the frequency. So lambda is actually equals to V over F, right? So I arrange back the formula so you can see the relationship between the lambda and also the frequency. Lambda is the wavelength, okay, the wavelength and the frequency. So here you can see when the lambda increase, right, the frequency will be decrease. Okay, so this is actually the relationship of inversely proportional, right? If directly proportional, it should be when the lambda increase, the frequency also increase. But for this one, if you increase the lambda, the frequency will become decrease. So this is actually inversely proportional. So which one is the inversely proportional graph? So the answer should be C. Okay. For A, right? For A, okay, so the graph can become directly proportional if you change the x-axis to 1 over f. So if the x-axis is 1 over f, you can change it to directly proportional. But lambda against f should be inversely proportional like this. Okay, so based from the formula here, okay, you can find the answer. All right. So for this one, what happened to the wavelength and the magnitude of velocity of water wave when it is reflected? Okay, actually, this one we already discussed about the wavelength and also the magnitude of velocity. Lin Hui, Xin Yan. Okay, good. So mostly of you give answer A. Okay, some answer C. Okay, some answer B also. Okay, but mostly A and C. Okay, A and C. Okay, only like 2 or 3 people answer B. Okay, but mostly got B. Alright, so let's see the answer here. So what happened to the wavelength and the magnitude of the velocity of water wave when it is reflected? So the answer is wavelength, okay, of course unchanged, okay, and magnitude of velocity, right? So the magnitude of velocity here, magnitude of velocity is actually should be changed, right? This one should be speed, not velocity. If velocity means it will change, okay? So this one should be the answer is, there is no answer because this one is actually speed, right? So remember here, okay, for the reflection of wave, right? For reflection of wave, the wavelength, okay, frequency, and then another one is the speed, right? Is constant, right? But the direction of propagation, okay, and velocity is changed, okay, and this is due to the change of direction. Okay, so this one actually no answer. If they said magnitude of speed, yes, both is unchanged. Okay, the magnitude unchanged, the speed also unchanged. Okay, but this one wavelength you can see increase, decrease, no. The wavelength will not increase, decrease. For the reflection will be constant. Before and after the wavelength will be same, right? Okay, so that's all for the reflection. Okay, so we move on to the refraction. Okay, so I repeat again what we are learned for the reflection of water wave. Okay, so reflection of water wave, we already see the video also. Okay, how does the water wave being reflect? Okay, by the plane. Okay, by the convex mirror, or and then a concave, right? So we already know how does it will be look like after the wave being reflected. So now we move on to the refraction. Okay. So diagram below shows seawater wave traveling towards a shore. Okay. So observe the wave and compare their shape when they are away from the shore and when they approach the shore. Okay, so wave refraction cause wavefront, okay, to parallel the shape of the coastline as the approved shore. Okay, so here you can see it will follow the shape of the shore here when it achieves to the shore or it achieves to the beach. Okay, you can see it follow the shape of the beach here, right? So this is caused by the wave refraction. Okay, so for this one, is asking you what happened to wave as they propagate to different depth of water. Okay, so this one is said a square glass slab is placed in the ripple tank so as to create different depth of water. So this one you can see is the deep, okay, deep area. This one only shallow because you already put the glass slab here, and this one is the deep area, right? So can you please try to answer this one? What happened to the wavelength? Oh, sorry, what happened to the wavelength? Maybe what happened to the wave when it propagate to the different depth of water? Maybe from the deep to shallow and then go back to deep area. Okay. So what will happen to the wavelength? What do you think will happen? It's okay, just try. Doesn't matter if you're wrong or right. We will discuss what will happen to the wavelength, what will happen to the frequency, what will happen to the velocity, what will happen with the shape of wave. Okay. So I give 30 more seconds for you to respond. Okay. So let's see your answer here. Okay, the wavelength decrease, become shorter, the wavelength increases. Okay, wavelength shorter at shallow area, wavelength will change. Alright, the wavelength decreases when the water in a shallow area. Okay, this one increase, the ripple of what wave will increase. Okay, and decrease from deep water region to shallow water. So mean the wavelength will be decreased. Contracted. Okay, the wavelength will decrease, don't know how to do. I think the shape of wave will change, okay, depending on the size of the ground. The size of the ground mean whether it's deep or shallow area. Is it, Alicious?
Yep.
Okay. Alright, and then the shape of wave in shallow area become more contracted and frequency more higher. Okay, and the wavelength at shallow area will have a high frequency than deeper area. Okay, so some of you got it correct. Okay, so let's see here. Okay, what can you see here is actually, right, the ripple is become more closer to each other, right? And this one is actually from crest to crest. We already learned in 5.1. Crest to crest is actually equals to the wavelength. So if we compare the lambda 1 and the lambda 2 here, the wavelength is become decrease. Okay, it decrease, okay, from the deep area to the shallow area. Okay, and then after that we already know V is actually is equals to F over F lambda, right? V is equals to F lambda. So whenever the wavelength decrease, the velocity also will be decrease. Okay, so that's why you see it state here V1 is bigger than V2. Okay, V1 is bigger than V2. If we compare the lambda 1 and lambda 2, lambda 1, the wavelength is bigger. So of course when the lambda 1 is bigger means the velocity of V1 also will be bigger. Okay, and for the lambda 2, okay, you can see the wavelength here is decreasing, it becomes smaller. So means the velocity will become lower. So that's why V1 is higher than V2. Okay, so here we can see what we can see is actually the wavelength, okay, is changed. Okay, it changed between the, it changed due to the difference of the depth of the water. Okay, for deep, okay, the wavelength area will become bigger. Okay, and then when it goes to the shallow area, the wavelength will become smaller, and when it go back to the deep area, it will become bigger. So we will see this on the ripple tank. Okay, so that's later we show you a video. So here it said observe the diagram. Okay, compare the frequency. Okay, for the wavelength, the frequency is same. Right, the frequency is same. The only thing that's changed is the velocity, okay, the wavelength, okay. So that's the only thing that's changed. Okay, the velocity and wavelength. The frequency is constant. Okay, so here it said compare the frequency of water wave in the deep area and shallow area. Okay, so the answer is same. And you compare the wavelength in the deep area and the shallow area. So here we already can see that at the deep area, the wavelength is bigger than the shallow area. Okay, for the speed, okay, for the speed, okay, so for the speed, okay, this one is actually, you have to change, right? This one, the answer is here, and this one is here. Okay, and then for the speed, okay, for the speed for the deep area is bigger than the shallow area. Okay, because we use the formula V is equals to F lambda. So when the lambda is higher, the velocity also will be higher. And then you have to relate the depth of the water and the speed of the water. Right, so let's see the diagram here. Okay, the depth of the water and also the speed. Alright, here you already see V is equals to F lambda. Alright, so here when the lambda increase, okay, the lambda increase, the velocity increase. So means the deeper the area, okay, the deeper the area means the higher the velocity. The deeper the water, okay, or the deeper the area, the higher the velocity. Okay, oh sorry, the speed. Right, so here the connection is directly proportional, or you can use this the sentence that I give just now. Okay, the higher the depth of the water, the higher the speed of the water, or you can say directly proportional. But remember this one, okay, you cannot answer the higher that one in the graph. Okay, this one, that one is only for the relationship. Okay, relationship of two variables, okay, in paper 2. Paper 3 cannot use higher. Okay, must use directly proportional, inversely proportional for the graph. Alright, and then the next one, you have to relate the depth of water and the wavelength of the water. So the depth of water is directly proportional. So this one I already proved, okay. When the depth of water increase, okay, when the depth of water increase, the wavelength also become increase. Okay, directly proportional. And you have to relate the speed of water wave to the wavelength of the wave. So this one also directly proportional. Okay, you just refer with the formula that is V is equals to F lambda. Okay, V is equals to F lambda. Whenever the wavelength increase, the velocity also will be increased. Okay. So any question you want to ask about the reflection of wave? Any question? Before I move on to the next one. Are you clear? Okay. I think no question. Alright. So let me ask you something. Mm, okay, actually this one I just repeat what I said just now. Alright. So let's say if the water propagate, okay, if the water propagate from the shallow area to deep area. Okay, first thing I want to ask, what is the wavelength? What happened to the wavelength? What happened to the wavelength? If the water propagate from the shallow area to deep area, what happened to the wavelength? Okay, shallow area to deep area. Okay, first one, what happened to the wavelength? Okay, number two, what happened to the speed? Okay, number three, what happened to the um, frequency? Okay, can you give me these three answers? A, what happened to the wavelength, what happened to the speed, and what happened to the frequency when the water travels from the shallow area to deep area? Whether it's decrease or increase, whether it's no change or constant. Wavelength increase, speed increase, frequency constant. Wavelength increase, speed increase, and frequency we have no change. Okay, others, there's always same people to answer. Okay, I want other people also to answer. It's okay if it's wrong. Okay, Chun Kiat, increase, constant. Kelly, increase, constant. Okay, alright. Very good. All of it correct. Okay. So from shallow to deep, okay, the wavelength should be decreased. Okay. And the speed should be decreased based from the formula V is equals to lambda. Lambda decrease, V also decrease. Alright. And then the frequency will not change in refraction. Okay. So this is what you have to know for the refraction. Okay, so after we see the ripple tank, the shape of wave, what happened to the wave, okay, after it being refracted? Right, so what is the meaning of refraction of wave? So as refraction of wave is actually the change in direction of propagation wave, okay, caused by the change in velocity of wave when the wave propagate from one medium to another. Okay, so this is actually like example here. Okay, so you see, let's say you put the straw, okay, inside the glass and you fill the glass with water. So you can see that the straw is actually like it bend. Okay, it's not in the straight line, it's like a bend like that. So means that the refraction is actually occur. Right? So why? This is because the light, okay, is travel between two different medium that has different density. Okay, so means air is less dense compared to water. Okay, air is less dense compared to water. Okay, so here means it's less dense. Okay, here is more dense. Okay, so means the light travel from the less dense to the more dense medium. Okay, so the light will be refracted. Okay, so actually what is the meaning by refraction? The refraction means, okay, when the light or when there is a change in direction of propagation, okay, caused by the change in velocity of wave when the wave, okay, propagate from one medium to another medium. So this is due to the difference in the density. Okay, so different due because of the density of each medium is different. So that's why the refraction occur. Okay, and the change of the direction of propagation also actually is caused by the um, density, right? So let's say I give you an example. Okay, so this is air and this is water. Okay, so this is the normal line and this is the incident, okay, incident rate. Okay, so here you know already air is less dense. Okay, the water is more dense here. Okay, so the light will propagate from the less dense to the more dense. So what will happen to the light? Is it will be propagate away, okay, away from the normal line or towards the normal line? I think this one you already learned. Form 2, I think, light chapter. It will refracted towards the normal line or away from the normal line, from less dense to more dense. Just guess whether it will propagate where the refracted angle. Refracted away from the normal line. Okay. Others? Away. Away. Only 2 people want to try. Away from the normal way. No, away. Okay. Actually, it will be refracted towards the normal line here, from the less dense to more dense medium. Okay, but let's say from water to air. Okay, so this one is more dense to less dense. This one should be refracted away from the normal line. Okay, so this one you need to remember. This is the basic concept of the refraction. So whenever, whether it's light, whether it's sound, whether it's water wave, okay, so any type, okay, any type of wave, okay, light is actually one kind of wave too, but that one is the electromagnetic wave, okay, but they can act like a wave, okay, so that can be refracted. Okay, so whether the water wave or the sound wave, okay, when they propagate from the less dense to the more dense medium, they will be refracted towards the normal line. Okay, so mean it will become closer to the normal line. Okay, but let's say it travels from the more dense to the less dense, it will be refracted away to from the normal line. So you can see here, okay, it move away from the normal line if you compare to this one. Okay, so that is actually the refraction. So refraction is caused by the different density of the medium. So when the different of density of the medium, okay, so because of the different density means there will be a change in direction. So the change in direction is meaning by here, whether it's refracted away or refracted towards, that is a change in direction, right? So that we cause the refraction. Okay, so this is the meaning of the refraction. Okay, the speed of water wave is influenced. Okay, I erase this one first. Okay, so the speed of wave is influenced by the depth of the water. This one we already know. Okay, V is equals to F lambda. When the when the area, deep area, the wavelength is increased. So wavelength increase, velocity also increase. Okay. So the speed of light is influenced by the optical density. Okay, so this one I mentioned just now. Okay, is influenced by the optical density. And this one also depend on the density, okay, for the sound, right? So the sound when it refracted is influenced by density of air, okay? So the hot air usually the density is very low compared to the cool air, okay? So the cool air will stay at the bottom side, okay, bottom part, and the warm air will go up, right? So later we discuss about this one when we learn about the refraction of sound. Okay, so we will see one by one. Just now we already see about the water wave, right? So after this, this one we see on chapter 5. Okay, sorry, chapter 6. Okay, light. Alright, and this one we will learn later on this chapter. Okay. So write an equation for the refraction of wave. Okay. So let's say if I have a two medium here. Okay. So let's say I put this medium A and B. Okay. So deep area region is A, shallow region is B. Okay. So we have the formula V is equals to F lambda. Okay. I put V1 lambda 1. Okay. And we're F1. Okay, and for this one is V is equals to F lambda, V2, okay, lambda 2 and F2. Okay, so remember I said just now, F1 is frequency is same, right? F1 is actually equals to F2. Okay, F1 is actually equals to F2. The frequency is not changing. So mean the frequency as region A and region B both have the same frequency. Okay, so here we if I arrange the formula back, V1 lambda 1, this one is F2 V2 over lambda 2. Okay, since the F1 and F2 the frequency is same, so I can just put V1 lambda 1 is actually equals to V2 over lambda 2 because both have the same frequency, right? Okay, so this is actually the formula for the refraction of wave for two regions. Okay, whether from the deep to shallow or shallow to deep area. Okay, so this is the formula to find the velocity of lambda for two regions. So this one you must have two regions to compare. Okay, so let's see V1. Okay, so F1 is equals to F2. So means V1 lambda 1 also is equals to V2 lambda 2. Okay, so that's the formula. Okay, now we see the characteristic for the refraction of wave. Okay, this one is for water. Okay, the angle of incidence, okay, if the water move from the deep to shallow water, okay, the I will become bigger than R. This one later we will learn how to draw the wavelength. Okay, and this one if from the shallow to deep water, okay, the I will be smaller than R. Okay, and for the speed, okay, from the speed, because this one is deep from shallow, means the wavelength is decreased. So the speed also decrease based from the formula V is equals to F lambda, right? So lambda is decreased, also the speed will be decreased. And about the wavelength, yes, the wavelength also will be decreased. And how about the frequency? The frequency is unchanged. Okay, and for the water that pass through from the shallow to deep water, okay, the speed will increase because of the lambda increase, okay, the wavelength increase, so the speed also will be increased and the wavelength also will increase, but the frequency will not change. Okay, about the angle, later you will see why the I is bigger than R and why I is smaller than R, because you have to draw. Okay. So this is actually how does the direction of wave, okay, change when passing from deep to the shallow water. Okay, so you can see it move, okay, it move towards the normal line. Okay, so this one you will learn later how to draw. Okay, and see the wavelength here when it comes from the deep. Okay, this is the wavelength. Okay, this is the wavelength. So you can see the wavelength is decreasing. Alright, and here from the shallow to the deep water, you can see the wavelength increases. Okay, so here it said refracted towards normal line, refractors away normal line. Okay, we learn how to draw later and I will ask you to draw. Okay, so starting from here, okay, so you have to draw a boundary line to separate the deep, shallow and region area. Okay, and then you have to label the region. Okay, so this one already being labeled to you. Okay, so this is actually the perspex plate. Okay, and this is in trapezium. Okay, so they put here the glass here. So this one will become the shallow part. This one is deep area, deep area. Okay, after that, you will draw the straight line. Okay, you draw one straight line. Okay, this is actually the incident wave. Okay, so how to draw the incident wave? You have to see, okay, where does the wave come from? Okay, so if the wave come from here, the source come from here, it vibrate. So mean the wave will move from the left to the right. So you draw the line left to the right. It must be in the straight line like this. Okay. And the next one, this is the important part. You have to draw the normal line. Okay, the normal line must be 90 degrees with the surface of the glass here, right? So here must be 90 degrees. Okay, from the surface of the plate here. Okay, all right. After that, remember I told you just now, okay, deep and shallow area. So deep, shallow area, okay, usually the density will be increase. Okay, the density is higher. So when the density is higher, what will happen? It will move towards or away from normal. Remember I just told you just now? Can you still remember what happened? Okay, I will put here denser. This one is less dense. One is less dense. Okay, so what will happen? Is it will be refracted away normal line or it will refracted towards normal line? Just now like air to water, right? From air to water. So the light will move towards or away from normal line? Hauren, yes, towards the normal line. So towards the normal line, so you can see it move towards the normal line here. Alright, very good, Hauren. Okay, so it move towards the normal line here. So this is the normal line. So it come closer to the normal line. Okay, and then after that, okay, after it entered the shallow area, so when you want to go back to the deep area, again you have to draw the normal line. Okay, you have to draw the normal line. And from this one, all right, now the water propagates to denser to the less dense. So it will refracted away or towards? Yeah, away. So now you see it moved away, right? It moved away. Okay, so this one it moved towards, okay, it moved towards the normal line here. It become closer to the normal line here. But this one, they move away from the normal line. Okay, that's how you draw the line first. You have to draw the direction of the propagation first. Okay, then after that, you make a line. Okay, so for this one, you draw a line which is perpendicular to the direction of the propagation. So the line that you draw must be 90 degrees from the line that you draw. This line. Okay, so you draw a straight line here. Right? Okay. And stop until here. So for this one, you have to draw it 90 degrees from this line. From this line that you draw. Okay, so you have to draw a line that is a 90 degrees from the line that you draw here. Okay, this arrow here. Okay, so you have to draw the line then the line must be 90 degrees. Okay, then you underline. All right, so from here, okay, so from here again, okay, you have to draw 90 degrees also from the direction of the propagation here, this error. Okay, so you just draw the wavelength, and the wavelength must be 90 degrees from the direction, from the arrow that you draw. So here you can see the wavelength here become, so this is increase, okay, and this one is decrease, and this one it increase back. So this one and this one is same. Okay, so this is how you want to draw the wavelength. So later I will assign for you, okay, I will assign for you in Google Classroom, okay, to draw this. Okay, and then another one also we have. All right, so this is the experiment. So they say you got chance, okay, to go back to school. Okay, so I will let you use the repel to see what is the refraction. How does the refraction of wave, water wave, okay, if you're using the repel tank. So this is the video. Wait for a moment. So refraction of wave in a repel tank. So the wave crossing a boundary from deep to shallow water. Okay. So from deep to shallow water. So this is the deep area, and they put the plate here. So at this area, the water becomes shallow. Alright. And this one is a deep area. Okay. So this one they put a glass. Okay. They put the glass. So the depth now is will be decreased, right? So this is become the shallow area, and this one should become the deep area. Right, so you can see the difference here. The wavelength is decreased, okay, compared to the deep area here. Okay, this one, the one that we just it's just almost same, okay. Because the trapezium is like, the one is the shape is like this, right? Okay, so this is the one that we see at the deep, from the deep to the shallow part. Okay, so you can see, you see the line here. Okay, right? So it become closer to each other. So this one is a deep area, this one is a shallow area. Okay, so this one, the deep area, you can see the wavelength here is very is high compared to the shallow area here. So not partially reflected or wave. So here you can see there's a partially the reflected or wave here, because the water wave hit the surface of the plate, right? Also, this is the deep area, this is the shallow area. So you can see the wavelength is decreasing. Okay, there's this one from shallow to deep water. Okay, so this one is the shallow area, this one is the deep area. So you can see the longer wavelength here compared to this one. Okay, this one also shallow area, then one is a deep area. So the wavelength is increasing. This one you can see the wavelength is very close to each other. Right? Okay, so this one you will see clearly when we do the experiment using the ripple tank. Okay, so I will stop the video. Okay, for this one, okay, wait for a moment. I want you to draw refraction wave. Okay. 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 Okay, so can you please draw this one for me? The wavelength for this one? It doesn't matter if your line is not straight, as long as I can see there is a difference in wavelength. Teacher, may I have the class code? Yeah, 72469. Wait, I put here. Why you suddenly left, is it? Oh, okay. Just draw. Come. This one you don't need to draw the normal line, alright, because the line is in the straight line. Okay, for this one, the normal line is actually on the direction of the propagation. Okay, only like if the line is not in the straight line, the surface is not in the straight line, then you have to draw the normal line. For this one, if you draw a normal line also, it will be on here, right, on the top of it. So it's because there is no angle of incident also. Just try. It's okay if it's wrong. I don't mind. I just want you to try. I give 1 more minute for you to draw. Okay, so let's see your answer. So still pending. Chia En, Lavanya, Vincent, Daniel, Lee Yongjun, Lee Yin, Lu Lin Jingyi, Lavanya, Yongwei, Yingwei, Kaiser. Okay, so let's see your answer. Alright, so for this one, this is the shallow area, right? So from deep to shallow, okay, the wavelength will be decreased. So you just draw the line and the line must be closer, okay, if you compare to the deep area. Okay, so you just draw a line. Okay, so here is okay if the line is not straight, but later in the exam you have to draw the straight line, okay, using ruler. Okay, then after that it go back to the deep area. So when you go back to deep area, of course the direction of propagation will be same. Okay, because it's the line is the straight line the straight line graph. Sorry, the straight line surface. Okay, you cannot draw a normal line also. If you draw a normal line, okay, this is the normal line. The incident line is actually on the top of the normal line. So means the incident angle is 0. Okay, so there is no incident angle. So when there is no incident angle, so of course you cannot do a refraction, because refraction, the angle of incident cannot be like in the normal line like this. You cannot draw the line, right? Okay, so here also you draw the line, the wavelength, but this one must be same like this one. Okay, the wavelength. So you just estimate, okay, make sure that the wavelength is same like at the deep region. Okay, so that's the answer. So let's check your answer here. Hmm. Okay. Hmm. Because the direction of propagation in this way, right? So of course, how you can draw the normal line this way? This is not 90 degrees to the surface area. Should be 90 degrees. So 90 degrees is actually this one, right? Okay. So mostly most of you got it correct. All right. Okay, so I noticed some of you, they got confused, right? They got confused because they draw the normal line here. Remember I said the normal line must be 90 degrees. So let's see if I have the surface like this. My normal line, it will be like this, right? This is my normal line, okay? This is my normal line. So my normal line is actually same as the direction of the propagation, okay? So you cannot draw the refracted ray. Okay, if you draw like this is not 90 degrees. The normal line must be 90 degrees. That's why we said normal line. Normal line is a 90 degrees, okay, between the surface. Okay, right, so let's see the next one. Okay, so please draw this one. Yeah, this one you can draw remember what you have to do first? Draw the direction of the propagation. So this one already draw for you. Okay, direction of propagation. Then another one, what you have to do the normal line. Draw the normal line of the surface. Remember just now I said normal line must be 90 degrees from the surface, means 90 degrees from here. Okay, so if you draw the normal line, it have to be 90 degrees. Okay, then after that, you can show whether it's away from normal or towards the normal. It depends. This one deep from shallow means from dense to less dense. This one go back to dense. Okay, so I give you some time to do. Only 1 minute left. 2 minutes left. Okay. I give 30 seconds, then after that I will stop. Okay. So still some of you already answered this one. Very good. Okay, I want to see. What is this white horn? Okay. I know maybe some of you have difficulties because you're using your mouse to draw. Okay, unless you have a tab or using a Microsoft Surface, okay, then you can draw nicely. Okay, so never mind, right? So I stop. Okay, so let's see, right? How actually you want to draw for this one? Okay, this one they already give you the direction of the propagation. Okay, draw the normal line first. Okay, draw the normal line first. The normal line must be 90 degrees from the surface. Okay, after that, from here, so this one from from the station is less dense to dense. Okay, all right, sorry. No, 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 no. This one, yeah, yeah, correct, this less dense. Okay, so less dense to dense, it become closer to the move towards the normal line, right? So this one, it moved towards the normal line. So this is a normal line. So it moved towards the normal line. If away, it will be like this. Okay? So this one is the less dense to dense. So less dense to dense move towards the normal line. So maybe that's why I see like elections right there. You are way like this, right? Okay, sorry. Um okay, so here and then after that, you draw again the normal line here. Okay, the normal line here. Do you have a class after this? Do you have an online class after this? What class after this? Yes, we have online class. Got moral next, okay. So can we continue this one on the next class? Online class, is it? You got Google Meet, is it? Yes, okay. So we continue this one on the next class, right? So thank you, class. Okay, so see you on the next class. Okay, so take care, everyone. Bye. Before I forgot, tomorrow we will start. No, on Thursday we will start the presentation. Okay, for your project. Okay, bye bye. Welcome.